Okay, we are determining the Bronsted-Lowry Acid Strength of this chemical reaction. First, we are going to draw in our lone pairs to determine the acid and base. Chlorine has 7 valence electrons. With the one bond, it has 6 little lone pairs. Nitrogen has 2. This Se, whatever it is, has 2. Okay, so from that, we can tell that this is our acid because it has the H molecules, and this is our base because that's acid. Positive. Okay, so we're going to start our arrows at the source of the electrons, which is the lone pairs on the base. And then we're going to take them and attack the H molecule. And then when we break that bond, we push 2 lone pairs onto the end and a negative charge. Okay, so to draw our products, we remove 1 H molecule from the starting and plop it over here. And then that leaves an extra lone pair on the N molecule and a negative charge as well. Just realized I didn't draw this in. Not that it matters much. Okay, so we know this is our conjugate base because it lost a proton. So this is the conjugate acid, which gained a proton. Stop it. Okay, to determine which acid and conjugate acid are stronger than the other, we look at trends on the periodic table. So we know that our first acid has chlorine in it and nitrogen, and then our other one has lithium and selenium. Sure. So we can tell that chlorine and nitrogen are very far over to the right side of the periodic table, where they are electron dense and higher in electronegativity than lithium over here. But because the Se is lower, it overpowers the electronegativity and makes this acid the strong acid. Strong acid. So this is our weak acid. This is our strong base and our weak base. Pause. Okay, because we know that equilibrium favors the formation of weak acids, which in this case is in our reactant side, equilibrium is gonna go towards the reactants. So the left. Reverse equilibrium. The end. Okay, so now we have to look at the pKa values of the acids. And this, the conjugate acid is going to have the lower pKa value. So let's go with 50. I mean 5. And this acid is going to have a pKa higher than that one, so 50. Stop.